So you want to introduce yourself?
I'm Wendell. I do stuff. I'm a computer janitor. I'm sort of glorified. We're doing this cross-posting thing. It's really weird. People can check out your channel, but I'm also posting it on my channel, so it's like places, but there's not a lot of overlap between our audiences right now, probably. So
No, and your audience is much larger than mine. So there's, well, I mean, unless you're talking about art, but it's like I've had some reach, but not with podcasts or whatnot. So thought I'd give it a stab.
well, for everybody
Uh,
in our audience, this is Bryan. You might remember pixel art Lisa Sue or pixel art me being chased by the boulder when Threadripper launched because Threadripper 3000 was an historic occasion. Very exciting. That comes to us courtesy of Bryan.
yeah, I also did the one for you because how I started contact with you because I'd listened to your level one tech for years, but I did like a couple of series of just images for YouTubers that I ended up using a lot of time. Like my day would be filled up by their content, so I'd always watch you guys and stuff on there. So I'm like, I'm gonna do an image for level one. I feel
You can't see
they
it,
would
but
appreciate it.
I pointed the camera at the poster. It's hanging up in my office, so I moved the
Okay,
camera so you could kind of see it. It's sort of fun, but
nice.
yeah,
Yeah,
it's pretty glorious, really.
yeah, that one was funny. I think Ryan's lying on the floor.
Yeah, I passed out. Yeah, yeah,
So
it's a
yeah, I
lot of
did
fun.
another one for like John Lennon. I did one more for Alex McCullough. But it's like I'm like, how often do you get it from like an actual professional artist? You know what I mean? It's like it's a
Well, it's
fun thing.
I wish we had Krista here because like artists that are also like super technical, kind of unicorns, and so you're definitely a unicorn because we've had some very super technical conversations, and the main thing on the agenda today is to talk about Stream Deck and
You
what
mean
that
Steam
means.
Deck?
Yeah, Steam Deck, yeah, not the
No,
Elgato
not.
thing, Steam Deck. I was so paranoid I was gonna do that. Yeah, Steam
It's
Deck,
okay. I
which
got your back.
you can stream with the Steam Deck from your Steam library.
Well,
So,
we're gonna get into that because that's part of the Proton layer, I believe. So
well,
this is,
is this the streaming part is, or I thought the Proton layer was for running natively?
oh, it is. But you said that you could also use Proton for streaming. I remember you telling me that.
Yeah, so you can kind of cheat a little bit, and it turns out that the graphics abstraction layers you can do some fun things. We know that from working on like the Looking Glass side of things, but that's a conversation for another day, or
Okay.
in a conversation for a little bit. We're getting ahead of ourselves,
Yeah.
but
And
yeah.
for anyone who doesn't know Wendell, I think it's funny because over the last like 3 years, I've noticed you also kind of became tech support for YouTubers on their obscure projects. Like you popped onto Gamers Nexus and Linus just when they're doing some weird server thing or something in Linux that's out of their normal range, and then you always show up on their channel. You were the first person that I wanted to talk to when the Steam Deck was announced. I guess I should probably introduce myself now, just in case. But I'm Bryan Heemskerk. I'm the lead artist at Massive Damage. I do art direction and stuff there as well.
We'll
I've
put a
worked
lower
in the game.
third in. It'll be fine.
Yeah, yeah.
Cool.
I've been sorry, worked in the game industry for 10 years. Shipped products on lots of different platforms, consoles, PC, phones, things like that. So, anyways, when it comes to the Steam Deck, I'm gonna hope to bring some of that kind of perspective. And Wendell was one of the first people I wanted to talk to because of this, because I really wanted more insight on the Linux perspective. I did ask a bunch of developers what it's going to be like. So for those who are listening that might not be aware, it looks like the Steam Deck runs on a version of SteamOS, which is based on a Linux distribution that you would know the name of, Wendell.
Debian, I think.
So it's based on this specific distribution. They're going to be doing a bunch of updates before, so it wouldn't be amazingly helpful to look into what performance is like right now because they're going to be updating Proton and probably the base Linux distro before release. So should be a lot of changes in that regard. But I have a lot of questions myself. So one of the things that I was interested in is like with Steam Deck, what are developers like? It doesn't look like they're releasing. We've reached out at my work. We haven't heard back from Valve yet, so I don't know the details on this. We have pretty good relationships with Steam otherwise, but one of the big things that we're curious about is there any way to target this directly? Because it sounds like to us from Valve's perspective that the dev kits are more or less just early Steam Deck, so you can at least do your QA on it. And that's good. Obviously, knowing how it performs might encourage people to make a different performance mode, or if there are specific effects that you see tanking it when you're profiling, you might reduce or have a low version of your game that, or medium version of the game that emits some of those effects or half reses them or something like that. But yeah, I'm curious what your thoughts are and what we would have to do as devs to target this. Like, to me, it looks like we would likely need to port our games to Linux, and I have thoughts on that. We can get into that, as well as target Vulkan as the API. And we don't want to target OpenGL. We do not want to target OpenGL. So
yeah, OpenGL was one of those things where the artists and the programmers, they didn't get together. They didn't go to lunch. They should have gone to lunch together a lot.
They should have.
It's hard to predict, but there's some really interesting things that have happened historically that suggests to me that Valve sort of knows what they're doing with how to handle this. And so the shortest answer is, I don't think you're going to have to do anything super special to target the platform. I think most of your work is probably going to be around the controls. But even that, I don't think is going to be a lot of work. And so if we look at what's happened historically, one really interesting thing, I think it was DirectX 9. There's this real-time Vulkan translation thing, like the DXVK, like the DirectX to Vulkan translation layer. And there's a couple of things that have spun out of that, some funded by Valve and some from crazy people that can see in 9 dimensions because they're super crazy programmers. And some of the things that have fallen out of that is like the ability to run certain older versions of DirectX faster than native on modern hardware. And it's because the older versions of DirectX on modern hardware, no one is actually bothering to maintain anymore. And having the real-time translation layer, if you fix all the bugs, because it's not exactly a one-to-one mapping, you get better performance kind of automatically. And
this is probably intercepting all calls for specific hardware features, and it's translating them on the fly to Vulkan. So there is, in theory, especially on a really unoptimized API, opportunities there for actually performance improvements versus.
Yeah.
But there's also a lot of opportunities for regression. Both are possible.
Yeah. Well, sometimes you get a hardware assist. So like the hardware of the day, couldn't do culling the way that modern hardware does culling. And so like you add a lot of overhead trying to deal with that programmatically, computationally, because now logic that you just loaded into a buffer and let the hardware deal with, you have to do a little bit of logic on. But if you get back some of the performance because all of that happens in hardware, then mostly it's a win. The specific example I'm thinking of is like GTA 5. Because GTA 5, I mean, it's a popular game, and theoretically, you would think Rockstar has actually put a lot of optimization into it. Of course, I can't 100% say that with a straight face, because half the loading time is improperly parsing JSON. I see you, Rockstar. I see what you're doing. But, theoretically, a lot of optimization has gone into that, and you can't run it online because you've basically modified somebody else's game, but you can run it a little faster on more modern graphics APIs than it would run on the older graphics APIs. Although GTA 5 is not the best example for another reason, which is they implement some of those. They added the support for that over the years. So
I have a question based on this. If you mind if I intercept for a second?
Yeah,
so obviously RDNA 2 has like a set feature set that's unlikely to get targeted on PC, right? Unless something helps, either the APIs take advantage of it or we target it more directly. So like, I think, is sampler feedback culling a new modern culling method? Do you have any idea what that specifically is as an RDNA 2 feature?
No, I have. It's relatively opaque because if you look at how Vega evolved into RDNA 1, they did a lot of really clever things with the architecture to carry forward some of the functionality from Vega.
I'm thinking of like what it's going to take to get the most out of this. Because if we just talk about the base spec, so it's like, it looks like probably 512 shaders. So it's double the shaders of a Switch, right? And it's double the clocks. So at just a stock flops comparison, it's basically a 4 times performance increase over a Nintendo Switch. And then when you add the architecture shift going from, what is it? It's basically equivalent to the 900 series, which was Maxwell.
Yeah,
on
yeah.
NVIDIA. So going from Maxwell to RDNA 2, I'd guess would be maybe like a 20 to 30% performance increase as well. So we're looking at something roughly 5 to 6 times more powerful than a switch. And uh, the question is going from a closed ecosystem where they can really target that, the 256 shaders of the switch and so on, versus an open ecosystem where we're more likely to lose performance from API overhead, just the way that the games are built, not being able to target it as directly, just what you typically lose. So, like, I don't know. What are your thoughts on some of that?
Um, there's a lot of things that are happening in parallel, like Samsung and the whole RDNA thing, and
Yeah.
mobile and the whole. So I think your numbers are a little optimistic overall because they're probably going to target much better power efficiency. And if we look at the
Yes.
last few desktop generations, it's like power efficiency, we're way on the other side of that bathtub curve. So,
Yeah.
I don't know. Your numbers are a little
They're off.
optimistic, I think,
Well,
but
no, I'm talking about theoretical performance, not in-game performance, right? So
okay.
I'm expecting it to be like, this is like if you talk about what the hardware is in theory, if you had both of them in like an environment where you could just write one game for each of them separately, as accurately to the point as you can, you get probably somewhere between 4 to 6 times the performance on the Steam Deck versus the Switch. But that's not the case because with NVIDIA's direct API for the Switch, the Nintendo API, you can target the hardware much more directly and optimize more directly versus the Steam Deck, where I'm not sure we're going to be getting that. So I'm guessing myself to see like a 2 to 3 times performance increase. That's like my lowest expectation. That's my low stance.
That's probably more accurate because I'm trying to think about like on the Linux side, there's the binary blob. We still have to deal with the binary blob, even though AMD GPU is pretty open. I don't think. I guess I would say that in terms of like, Steam Deck as a Switch thing, will somebody target that specific set of hardware? I don't think. I don't think so. I don't think Valve will even want you to do that.
But
Um,
I'm not talking about hardware. I'm talking about features. Okay, so let me give you a really specific example. This might help it out. So, um, sorry, Vega and Vega 56 and 64 introduced half floats, right,
yeah.
in your workloads, and we saw them used in literally no games on PC, even though they're used on console games fairly regularly on the PS4 Pro as a means to push the performance higher. And you see it even on Switch because the Switch can do half floats, which is odd because Nvidia disabled it with the 3000 series. By the looks of things, you get same half float performance as full float at
Uh,
32-bit versus 16.
that's
I
interesting.
think.
They
I
probably
think.
they probably did that to avoid competing with their workstation cards.
Mm.
A
I'm
whole other
curious. Okay.
dimension of crazy.
Well, so the funny thing is that NVIDIA added half floats to the 2000 series, and we actually saw a small pocket of games targeted. I think Wolfenstein 2 did. They targeted half floats so that we have mixed precision workloads in there. And then what happened is you would see all of a sudden, if you look at those benchmarks for the game, Vega 64 and 56 would jump up a couple slots in their GPUs when this feature that was never used, it was never targeted for Radeon, was finally available on a set of NVIDIA cards too. Then you saw some games start to utilize it. There's a bunch of things that we can start targeting in engines, but they have to be in engines available for developers to implement easily for us to see performance. And there has to be incentive on PC. And this is something I mentioned on Moore's Law is Dead, is like game developers are hoping that like the minimum spec on PC shifts to like a 3060 or something. So we can at least have our full feature set to target.
So I think the answer to that, one of the answers to that is why that has not been the case on PC is because I think probably the lag time between the drivers and the hardware and then like the game engines. Because on a
Mm-hmm.
console platform, that time is basically zero. If you look at some of the experiments that we've done with Unreal Engine,
Mm-hmm.
some of the ray tracing stuff in Unreal Engine, the functionality is there in AMD cards, but like the development environment for developers is a little sketchy and unpredictable in weird ways.
Well, so you're talking about the 6 months lag time pulling into PC versus consoles. I mean, console time, the feature can exist right away, right? And then AMD would probably work with the vendors, but then getting engine integration and patches within engines. And the other thing that a lot of people don't know about games is a lot of times game developers, if they start developing a game, and I know we do this in Unity, and I'm sure Unreal developers do it too. If you're working on a stable build of your game and you're in a stable build of that software, you can be still using that build 2 years out. You can be on Unity 2016 or Unreal 2016 for your game
Yeah.
because you're more scared of introducing new bugs than you are of getting these new features. And this is what like usually what happens when you start a new game. Then you're like, oh, let's jump to whatever the latest build is right now that we get. Even you Google it a bit and see which is the newest build that's stable, right? And then you start building your new game in that, and then you get a chance to play with those features. But oftentimes, from the vast majority, I mean, there's some very technical developers that are willing to do the hurdles to get more of the features in all the time. Like, obviously, the developers of like Control and Metro and all of that are crazy when it comes to stuff. Most of them make their own tools and stuff, but for the average developer, you know, they want to make sure their game is stable, so they're a little bit scared to implement these new features.
Even outside the game engine, you have the exact same thing. Just like looking at the AMD GPU driver, it's like, oh, variable refresh rate. It's okay. The hardware is there. The primitives are there in AMD GPU, but does the compositor handle that? Is this a Wayland compositor thing, or is this something we're going to port to, you know, something for like pre-Wayland?
It's kind of interesting when like a lot of people don't. I mean, the last few games that I've worked on targeted PC first and spec'd otherwise, but AAA developers often do the inverse. They'll start on console and then they'll port to PC. I remember when I was at GDC 2018, I had a sit down at a restaurant with someone that just did, at that point in time, one of the most successful PC ports of a game. And I'm not going to mention it because just in case, but they did, and people were commenting on how well optimized and whatnot this specific PC port was. And that developer told me that they wished that they never had to port to PC. And I thought that was a really funny perspective, right? From this developer wishing that PC didn't exist as an ecosystem after doing one of the most successful optimized PC ports. The big problem with PC from a developer's standpoint is it's very hard to target it directly, right? Yeah. Like they're not sure what to look at. So like if the Steam Deck became like the lower end standard of it and they had something to shoot for that they can guarantee that, and it really depends on adoption, because if it sells, even if it sold, I'd say, you know, 4 or 5 million units in the first year or two, it probably wouldn't be enough to move a needle. But if it sells 20, then all of a sudden people are going to start looking at it, or 30 million, you know what I mean? So, and this is kind of why I wanted to get into the specifics of it. Like, what happens if it just took a giant portion of market share? What would we have to change in our development structure? Would we end up, you know, would that just be targeting Vulkan and porting to Linux? Now, I messaged just a bunch of developers I knew had done Linux ports in the past. And the perception was kind of, I'm not going to say anyone specifically, but they basically, most of them said that they were one of the hardest people to please because they would spend all of this time porting and then they would release it and they would get more negative reviews from Linux gamers, even though they tried really hard to release a Linux distribution, like a Linux version of the game. And then if they just didn't release the Linux version, they would have less headache and they would just play it on Windows somehow, or either through a virtual machine or whatever they do to play it on Windows, and they wouldn't end up complaining about the Linux port. And that was that perception.
I like what is happening with Proton, and I'm really excited by it, and it is a really great, amazing project. But there's a part of me that thinks, like, you know, all of the cruft and insanity of Windows, we're bringing all of that along, trying to, you know, deal with that layer. But at the same time, the environment has got to be better than what it is on Windows. And I think that a lot of developers don't have that experience. Because, like, the lower levels, like the kernel and the command line stuff and that kind of stuff for Linux it's the pinnacle of civilization. You know, modern man, it's like the greatest thing ever. But then, you know, the graphical environment built on top of that really isn't that amazing.
This is kind of Linux's biggest problem in a nutshell, that it doesn't have people fine-tuning the interface to make it more manageable for them. And those people would be luring the artists into the ecosystem, right?
Yeah, and there's not often not enough investment in that, because, you know, open source, the love of open source, you know, it's all really great and stuff, but it takes spending a lot of money. And I think Valve has done it right. Valve has greased an ungodly number of palms, probably untold dollars, but they don't want to talk about it, and they don't want their developers to talk about it. They just find people, and they're like, "You're really good at doing what you do. This is the general direction we need you to go in. These are the technical requirements. We will fund you if you want to do this. Just, don't talk about it. Don't make a big deal about it. Just go." And, the cat kind of came out of the bag surreptitiously with like DXVK and some of the other stuff. It was like, people are working on this. I don't know what the details are behind that, but it seems like a little cloak and dagger, a little bit intrigue. Maybe the story's more interesting or the imagined story's more interesting than reality. But it is really exciting that those things, and we will get there eventually, like supporting legacy and supporting old stuff and supporting this, that, and the other. We will get there eventually. I think here's something maybe that you haven't thought about, but is very related to what we're doing. So with the Switch, the Nintendo Switch, and also, Valve's Steam Deck, got that right, yes. The importance of that thing doing computation is getting to be less and less and less important, which dramatically increases the device lifetime potentially.
The kind of the beauty of the Steam Deck is running these things at all at 15 watts, right?
Yeah. I mean, you could play it locally. It could be a thing. It depends on the game, I guess.
Yeah.
And the network connection and all the other stuff. But the thing that changed my mind, I thought along the same lines, but what changed my mind was I built a Pi Boy DMG, which is It's a Raspberry Pi, vaguely reminiscent, but for the purposes of copyright, entirely distinct from the old school Nintendo Game Boy. And it's got a decent, but not high resolution at all. It's like 640 by something LCD screen, and it has a reasonably long lithium polymer battery life. And you've got all your classic games on it and your emulators, and it can play some stuff locally, but it is also a heck of a machine for streaming from Steam. And I've done the Wi-Fi hotspot thing off of my phone and streamed to that remotely with a VPN, and it's not been a completely awful experience.
I mean, latency is always an issue when it comes to streaming these kind of things, right? And the not necessarily that the moment-to-moment latency is bad, is that crucial moments of latency can hit you in a way that maybe wouldn't hit you locally. And I just weird spikes or outages or things like that. I mean, that would hurt you if you're playing an online game anyways, but it's weirder when it's your entire video feed. Like you feel like you're cut off from doing anything at that point in time. So it's like I can see somewhat that being the future and streaming your desktop onto the Switch, but onto the Steam Deck. I mean, I'm curious to see what this device can do, right? I'm wondering if, because the big thing we were talking about earlier is like we're talking theoretically 4 to 6 times Switch performance in game, maybe less, maybe 3. Would having a game ported directly to Linux and Vulkan, what percentage of that do you think we could scrape out of this device?
I think if the platform is optimized to the nth degree, I think that will be surprising, because I always go back to like the Doom Eternal port with Vulkan and the performance they were able to squeeze out of that. When that game launched, it was jaw-dropping. It's like, is this what an optimized game with Vulkan looks like? Because it was insane.
You and I, we never published it, but you and I ran some tests on variable rate shading and variable rate shading and mesh shading. When you run those demos on 3D Marks, it's like you look at variable rate shading and it seems to have a slight, tier 2 seems to have a slight performance advantage on Radeon compared to NVIDIA from a base. It's close, but it seems like there's a slight advantage to Radeon with variable rate shading. And with mesh shading, it's kind of weird because the NVIDIA demo starts out at a much higher frame rate than if you run the same test on a Radeon, on like a 6900 XT versus a 3090, but the performance gain percentage is much higher on a Radeon with mesh shading on. So part of me is wondering, like, we're not technically fully utilizing the Steam Deck until all of these features are turned on.
Yeah.
From my perspective, we're not seeing what the hardware can theoretically do until we're using its full feature set.
Sometimes that never comes to pass, though.
We have historically. So this is the question that I'm saying is this device going to make a big enough of a splash for that reality to come true?
I was thinking about, as you said that, and porting and the available features. Have you seen some of the insane projects? Like, people have ported Mario Brothers, or a Mario Brothers-like game that is similar to, but for the purposes of copyright, wholly distinct
Yes,
from,
yes. Yeah, yeah.
the Mario on an Atari 2600. It's like, we can play Super Mario Brothers on an Atari 2600? Yes, but not really, because those development tools did not exist at that time, and it also looks way different, but it plays similarly.
Steam Deck targeting hardware, right? This is kind of what all of this comes down to. Is this something we can target the way that we want to target? It's like I see all of these YouTubers specifically. It's like my themes being filled with Steam Deck things, with all these people being excited. And it's like I think immediately it will give you everything up to PS4 portable, right?
Yeah.
Like you'll be able to play all of your games up to PS4 basically portable. And some of the higher end games might not run as well as you like, and some of them might run way better, like Doom Eternal, or I would bet even the Decima engine games would probably run pretty well. But like Death Stranding or Horizon Zero Dawn, there's specific things that I think would target the hardware well and work well on it, and then there might be some surprise cases where it's just like this doesn't run that great.
Yeah. Yeah, I think that's. I think that's likely, but I think the thing that is going to surprise everybody about this, the hardware, is that it's going to have longevity that the Switch probably doesn't. One of the great things about the DS and like the original Game Boy, like the clamshell Game Boy, is that you can just pick one of those up and you can play the old games, and some people do that, and it's basically works from now until the end of time. I hope it's like that with this, where if you've got your whole library on it, you get the 1 terabyte model, you can just pick it up and go. Steam kind of wants to be online, it kind of wants a whole bunch of other stuff, but it would be amazing if 10 or 15 years from now, like some of Nintendo's products, you're able to do that with a PC without sort of needing good old games to have containerized it in some way so that it runs in a modern way.
There's not going to be like Proton 5000 that just translates everything to Vulkan no matter what.
I mean, maybe that could happen. But I think that because that device will have such a very long, useful lifetime, I think that the kind of porting that you're talking about is kind of inevitable if it gets the numbers, because it just builds cumulatively. If they do like a second version or whatever, it's like, well, we can count on H.265 streaming for both of these. And so even if it doesn't run natively, you could still stream it. And it's a little bit of a second class experience, but at the end of its useful lifetime, it's only just doing streaming. But that's that's fine. That kind of makes sense. I think that'll work well. If this thing is as popular as I think it'll be, it will probably have a cult following from now until the end of time. And
look at Vita, right?
Yeah.
Vita's very much like that. Like the PlayStation Vita has more. It had such a short window of active developer support, but the thing just lives on despite that.
Hackability and openness. It goes back to the thing that you said at the very beginning, where it's like, it's closed, now it's open, and then look, it lives on.
Yeah, it lives on. Well, most devices are hacked initially just to put Linux on it, right? So it's like...
Can it run Doom?
I was going to say, so it's like, I bet your forums are already on this, right? It's like, what's this? This is like the livelihood of your forums. We're like, oh, we're going to get like a community that is going to be maybe even a bit bigger, that when we write stuff for, they're going to be looking for our software immediately to use. And it's like the window of people accessing and modifying their software is going to go up dramatically for a period of time, right?
Yeah, this is kind of a no-brainer though, because look at like the GPD Win and other people like that. That's like, I'm going to build a device that is exactly what I want. And on the forum, to your point, there are a lot of people that are taking devices like that, and they're like, I'm going to take it apart and modify it. I'm going to do a replacement motherboard for this thing that I think that they got everything particularly right. I can keep using the input peripherals, no problem. But, so it's like, I can do a hardware replacement on this, horribly ancient thing with something that's a little less ancient. And even though it's proprietary, having a custom circuit board made these days, I can probably get some other people to do it with me and Kickstarter it, and we'll be good to go. And so like GPD did that, and now GPD has like a whole line of stuff that's basically kind of a predecessor, and it's been insanely popular.
Do you think this is going to have a significant shift in Linux adoption for average consumers? Obviously, Linux is crazy in servers and several other places, but I mean for the average user,
I think
it'll be the biggest uptick.
I think it'll have a knock-on effect, But I think the fact that Linux is in play is completely transparent to the end user. Like the fact that Android, has a Linux kernel underneath hasn't really mattered for Linux adoption. And so in this same context, I think that that is still going to matter. Now, will the work that Valve is doing be lift and shiftable over to the Linux environment? Yes. And ultimately, I think it'll be up to game developers and members of the community to do that. I don't think it's going to fall out of having this with no effort. So you'll have a positive knock-on effect, but I don't think that you're going to have a market where people are like, yes, I must have the Linux.
Okay. However, the only thing that I could see maybe changing that is if like Linux developers, like, or just individual people that write things for Linux, write such useful programs that people are drawn to the platform from like, oh, I have a Steam Deck and I was able to pull this cool mod in, or is able to do this, right? And modify the game or the ecosystem in this way that's really interesting. And then they go to Windows and they're locked from being able to do that. Those kind of things can be more persuasive, right? For the average user. They don't want to go nitty gritty with code. They don't want to go like trying to figure these things. But if there's a feature that they find easy to implement and use in a specific ecosystem that they can talk about and communicate easily, right? That has potential to catch on.
I was going to say, Microsoft is ahead of you there, and this has already played out for web developers. So like web developing, depending on what you're doing and depending on the languages and a whole bunch of other things, doing certain kinds of development on Mac, like Brew kind of sucks, and the old Bash kind of sucks, and like Mac OS is kind of rotting from the inside out. Like it's a pretty veneer, but there's a lot of bugs, and if you're a developer, it's a special kind of suffering. And Linux has a different kind of suffering, and Windows is just completely unprepared for doing, that kind of development on the web. But the Windows subsystem for Linux, oh my gosh, it is transformational, because you can have your little sandbox. You could run Docker or micro Kubernetes or whatever. You can have your little environment on your Windows box that's just like your server box in the cloud. So Windows finally now, with the Windows terminal and everything else, it is an incredible first-class experience for those kinds of things. So if somebody does, to your point, if somebody does write a really amazing widget that makes life easy and does some stuff on, Linux, blah, 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 it's immediately available on Windows. The reverse is not true. On Linux, if you want to be able to run Windows stuff, your only way to do it now is like seamlessly run a virtual machine. And we're, as far as I know, the people that are always writing the how-tos and doing the stuff on that so that you can run your Windows apps seamlessly on Linux. But you're basically running a full-fat virtual machine. You can do a full-fat virtual machine with GPU acceleration, but that's the only thing that has guaranteed compatibility. And if it's not for anti-cheats, that works really well for gaming too. And we've also got some technologies that'll let you, run an accelerated game transparently alongside Windows and the how-tos and stuff that go with that. And now we have some questionably okay with the manufacturer scripts like vGPU unlock, which will turn your GeForce card into a card that can actually share a workload between two different heterogeneous operating systems.
Now, is this where IOMMU groups come into play?
Yeah, IOMMU groups come into play when you've got multiple GPUs and you need to separate one GPU in one group for one virtual machine versus another GPU in another group for another virtual machine. Which
I think I heard Robert Halleck in a talk from AMD, it was like a technical talk, literally say IOMMU groups and said Wendell will get a kick out of this. And I'm like, did Robert Halleck just nod to Wendell?
I literally was the guy 5 years ago that showed up and was like, we need to get on top of this because, look, if you're going to have like all the old operating system baggage, I think that like for computers, computing in general and computing hygiene and security, we cannot spend the time. The human existence is too amazing and too awesome to force people to work on this. When we make a mistake, we should be able to abandon the past. But instead what happens is we have to maintain that mistake until the end of time. And so whatever weird quirk the Windows 95 API had for calculating the date or whatever you had, there's thousands of man years of programmer time to be able to support that. All the weird quirks and crazy stuff that's in Proton for dealing with Windows games is recreating something that already exists and is miserable on the Windows platform. look, if we can just figure out this virtual machine thing, we can package it all up in a container, and when we need to go into the past, we can go into the past in the container, but we are not encumbered by it.
It's kind of funny that you mentioned that, because this makes me think of Microsoft's strategy for Xbox specifically. And maybe I'm misunderstanding something because I'm not a genius on any of these fronts, but it looks to me like Microsoft shifted its game development ethos from hardware specific to API, like treat Xbox like an API.
Yeah.
And if you look at what they do with like retro, it's like Panzer Dragoon Orta, which is like a crazy old Sega. It's an original Xbox rail shooter made by Sega, and I love that game. And it just runs natively on 4K on if you play it on an Xbox One X or Series X. And it's crazy to see this game from, I don't know what, 2004 in 4K all of a sudden, like no jaggies, like perfectly clear. You're like, this is really interesting. But they couldn't do that if they weren't treating their entire ecosystem like an API.
Yeah.
And then so it's like it's a completely different way to target game development. It's very different than what you see from, and it's closer in a lot of ways to what Steam is doing. So it's kind of interesting because I listened to someone, I'm trying to remember who it was to give them credit where it's due, but they were talking about how Steam, they said it like a month before the Steam Deck came out, and they were saying that Steam is the only person that could pull off a handheld like this because when you look at GPD Win or the INEO or things like that, they can't hit economy of scale.
Yeah.
It's impossible, and they can't recoup hardware costs in software sales. And that's the only PC player that has the chance. Well, there's only two PC players that have the chance to win in that space, and that's Microsoft and Steam. Those are the only two people in that ecosystem that could actually pull this off.
Yeah, a lot of this archetype, this paradigm, the thing that I'm spouting is not anything new, even in terms of like the computer science architecture of it. There's a thing in Windows called Windows side by side, where different conflicting versions of things are maintained. And that's one of the ways that they're able to support 47 billion versions of .NET and the applications that are built in them, while they can update the version of .NET without retroactively breaking any applications. And so, people inside Microsoft know the pain and suffering and misery of trying to support old stuff. And it's like, well, the more we can stuff that into a box to where we don't have to deal with it, then the better off we're going to be.
This is the talk, like we can go back to where engines are going. There's two things I want to say from this, because obviously there's a push in the game industry to have, because your pixels are set, right? And what people don't understand with your game development and with your LODs and stuff like this is your scene is variable, and you make LODs that you set at specific distances or whatnot, right? But sometimes you have like a character model really close on the screen, right? And it has like 7 polygons, or maybe that's exaggeration nowadays, but like it's 100 polygons.
2012
right?
Tomb Raider, woo!
Yeah, it's like 150 polygons filling up like 20% of your pixels, right? And in the far background, you have like a mesh with 60,000 polygons in 4 pixels, right? So it's like, and this is what Nanite is trying to solve in Unreal, and there are other solutions that I've heard of tried for this, because I mean, the render workload for rendering the pixels should be the same, but it's not. But it's so data heavy to do that. So you have to manage your data to be essentially rebuilding the scene on a frame by frame basis to use only the pixels that are necessary. And this is this is the one thing I wanted to say from this. And there was another thing that I wanted to say from this. I was trying to remember what it is. So yeah, hardware vendors are attempting to do this, right? To target specific, and mesh shaders are a means to this to some extent, or closer to it, right? Just that your meshes are doing that automatically, and you don't have to make all of the LODs.
The computer science hadn't been invented yet, but we're getting to the point where we do have the computer science, and you do see things like this in the engines that you have. And so those kinds of things will make how much horsepower you need more a function of GPU horsepower than future upgrade technology. Like, it's kind of a curve. It's like, okay, we're going to add a ton more computational horsepower, but it didn't really matter. The reason the algorithms, the reverse of this is really easy to understand. You look at the 3090 performance. Look at the 3090 performance at 1080p. it's basically the same as 1440p. It's almost the same as 4K. We know that the 3090 can do the computation. Why is it not 4 times? And the answer is the software.
Well, it's partially the software. It's like it is much harder on the okay, so it's harder on output, but not everything in your scene it changes, right? It's like you're still mapping the same textures onto your meshes. You're still mapping some of these things scale with little performance loss, and some of these things scale with massive. It's just like alpha transparencies and blending on pixels that murders it, right? So it's like if you have like 4 explosions in the foreground and they're all like semi-transparent and they're blending with pixels behind it, the computation on that is insane, right? Versus some things like there's almost no difference on your hardware in terms of how many pixels it's targeting, and then other things there's a lot of difference, which is why it doesn't scale completely linearly from resolution to resolution, as some things just use different hardware and some things don't actually push, they don't need the scale. I did think again of what I was going to say before. Oh, some of what we were just talking about is the reason. So like when I was talking with Moore's Law's dad about the draw call issue, and if you work in a game studio, you hear the word, especially if you're targeting PC, you hear draw calls spoken more than almost anything else, especially when you're in the optimizations phase of games. And the whole issue with why it's an issue, because I think it was Oxide Games who did Ashes of the Singularity and whatnot. And before that, they had another game. But they talked about how they thought it was funny because when you worked on consoles, you'd have 20 times more draw calls than doing PC in DirectX 11. And that was because at the time, right, it's like DirectX was just built on top of all the previous versions. Going back to like DirectX 1, and this is before we had fixed function hardware. We didn't have pixel shaders. We didn't have unified shaders. We didn't have like any of these things in a GPU, right? It was like, wasn't even called a GPU. It was called a VGA card or whatever.
Yeah.
So it's like, and people were using it in either their AGP or their PCIe slot, or PCI slot, not even PCIe, and it's like, I remember those days. I had a TNT2 and a GeForce 256 and all of that stuff going back, but it's like the software was trying so hard to keep compatibility that it ended up creating massive bottlenecks in the pipeline. So it's like, how often do we reinvent the wheel is kind of the question.
Yeah, some of it, it's just the evolution of the methodologies that we use for rendering and for this, that, and the other. And, ray tracing throws a big wrinkle in all of that, because nobody thought that we would be doing real-time ray tracing now. And so now that we are doing real-time ray tracing, that's opening up a whole other set of computer science that needs to be done in order to get it back to we're filling up a finite amount of pixels. How much horsepower you need to do that should be a function of number of pixels, not necessarily what's going on them. Or at least the horsepower should be dominated by number of pixels and detail, I guess. Until ray tracing, the way that it was is if a tree falls in the woods, it literally does not make a sound. Not only that, the tree doesn't exist. So the problem is, imagine that you're looking in a room that's filled with marbles and lights and all kinds of stuff. If you're looking at stuff and you're doing ray tracing and the stuff that you're not looking at doesn't exist, then things get weird with the ray tracing, because the light is bouncing around the room, and all of the stuff that you were previously culling and all of this magical computer science we've been doing up until ray tracing, which what we're talking about is magical stuff to do a whole other layer of culling with like simplifying meshes and reducing the complexity of models that are far away because you can't even tell anyway. Think of like a more ghetto fabulous version of this is like the texture pop in like Wolfenstein, because it's like, hey, we're not even going to bother rendering this until we can get it just right. And then it's like, oh, look, it's suddenly more high fidelity. But ray tracing just takes all of that and just, because the reflections depend on stuff you can't see necessarily.
Well, you can summarize it pretty easily. So like one of the most common reflection methods used today is called screen space reflections. But when you see in games, literally the second you get in front of it, so if your head is blocking it, you'll see like weird lines going up and down off of your character's head, blocking the reflection, where it doesn't have that. So what we're talking about here involves, I think it's called the camera frustum, which is everything the camera sees, right, exists, and then anything outside of that space doesn't. And the problem is when you bounce a ray, it's looking for something that may not be there. So it could bounce up and down and behind an object and catch like the backside of an object, right? Or it can bounce off screen and hit something. And suddenly you need visual information that you didn't need before, right? And this is the nature of why ray tracing makes some things more difficult, right? And sometimes they just I don't know what Ratchet and Clank solution is. It looks like they just do it at a lower resolution so that it's basically doing another version of the scene with not necessarily identical assets. Sometimes they're lower quality assets to try to speed up the process of that being a secondary scene. I mean, GameCube did weird versions of this with like Wave Race, where it had a second camera that it was rendering everything to, and then it was combining them again. But
that's cheating.
Well, I mean, games are cheating. If you ever work in games, it's like the mystery around games dissolves immediately when you're like janking behind one of these scenes to create visual effects. It's like you're making things just warp weird, or it's like the second you look behind the camera and you look at a scene from the side, you're like, what is going on? I mean, rasterization is that in general. It's literally, as far as I'm aware, it's changing the textures and all the objects. It's modifying them to the camera's perspective. So if you could set another camera in the scene that just kept all of the textures being distorted and stuff off of the initial camera, you would see the crazy looking scene. It wouldn't even make sense, right? And that's why rasterization can happen so quickly. But I don't know, we're kind of going all over the place, but it's
that's
fun.
But all of this has to do with the new thing
Steam
from
Deck.
Valve
Yes.
game hardware, like the developer side of things. This has been a fun chat. Well, I hope you've enjoyed this Level 1 ramble with me and Bryan. Be sure to check out his new channel and all the fun stuff that he's been working on. And there's probably a longer unedited version of this, or less edited version of this, that's available on his channel, so you can check that out.
Well, I don't even know. I might just wait for the version from you.
No, 2023 is like, okay, there we go.
Yeah. But maybe I'll put the unedited version live, or I'll do a quick edit of them myself. But yeah, thank you so much for having me. Thanks for taking the time to talk.
No, thank you for talking with me,
insights.
because for what you do, you are a really incredibly talented artist, and having the technical perspective also just saves me a lot of time from having to like try to figure out how it relates to the stuff that I'm already interested in. So it works out a lot. There's definitely some self-interest in being able to talk to you and understand your perspective on industry stuff, because you get what's happening with the shader, you get what's happening with the render pipeline, and you get what's happening with the hardware people are going for, because really a lot of this stuff is educated guesses they made 5 years ago that's just now making it into hardware, because that's the life cycle that we're dealing with. And so,
well, I have like a bare minimum understanding. Like I see some profiling. I see, the typical, hey, what's this? Why is this taking up so much time in the render pipeline, right? This like stuff that it's part of all of this, but it's not like I'm want to find out even more, right? I'm looking to have like, part of the reason I want to do this is just talk to developers who've gone even more in depth, right? Like the ones that have scraped that little bit of processing out of the corner, right? Or found some kind of workaround that saves a bunch of time. But thank you so much for your time, Wendell.
Thank you.
It's
all
no,
good.
it's always great to do this. If you ever want to do any pixel art collabs in the future, you just feel free to reach out. And
I heard there's some new Threadrippers coming out. I don't know. Sometime, maybe. I don't know.
Yeah. Anyways, so yeah, catch this on Pixels Refreshed and on Level 1 Tech in 2023.
Cool. We'll see you there.